The Eiffel Tower, an iconic symbol of Paris and a marvel of engineering and architecture, possesses a fascinating secret. It grows taller during the scorching summer months. This captivating phenomenon is a result of the thermal expansion of iron, a principle rooted in the fundamental properties of materials science. As temperatures in Paris rise during summer, the iron in the Eiffel Tower expands, causing the structure to increase in height by up to 6 inches. This temporary change is a testament to the dynamic nature of the materials that build our world, offering a unique perspective on structural engineering and the physical laws that govern it. To understand why the Eiffel Tower grows taller in the summer, we must delve into the principles of thermal expansion. Thermal expansion is the tendency of matter to change its shape, area, and volume in response to a change in temperature. When materials, such as iron, are heated, their particles gain kinetic energy and move more vigorously. This increased movement causes the particles to occupy more space, resulting in the expansion of the material. The amount of expansion depends on the material's coefficient of thermal expansion, a measure of how much it expands per degree of temperature change. Iron, the primary material used in the construction of the Eiffel Tower, has a relatively high coefficient of thermal expansion, making it particularly susceptible to changes in temperature. The Eiffel Tower, constructed between 1887 and 1889, stands at 324 meters, 1,063 feet tall, including its antenna. It was designed by the French engineer Gustave Eiffel, whose innovative use of iron allowed for the creation of a structure that was not only tall and slender but also remarkably strong and flexible. This flexibility is crucial for accommodating the thermal expansion and contraction that occurs as temperatures fluctuate. In the summer, when temperatures can soar above 30 degrees Celsius, 86 degrees Fahrenheit, the iron in the Eiffel Tower expands. This expansion causes the tower to grow by up to 6 inches, a change that is both measurable and visually perceptible. The expansion of the Eiffel Tower during summer is not uniform. Different parts of the structure expand at different rates depending on their orientation and exposure to the sun. For instance, the side of the tower facing the sun will expand more than the side in the shade, causing a slight tilt towards the shaded side. This tilt is temporary and corrects itself as temperatures equalize across the structure. Engineers monitor these changes to ensure the tower's stability and safety, using sophisticated instruments to measure the tower's height and tilt with precision. The phenomenon of thermal expansion and contraction in the Eiffel Tower highlights the importance of materials science in structural engineering. Engineers must account for the thermal properties of materials when designing structures to ensure they can withstand temperature fluctuations without compromising their integrity. This consideration is particularly important for tall, exposed structures like the Eiffel Tower, where temperature-induced stresses can have significant effects. The dynamic nature of the Eiffel Tower, growing taller in summer and returning to its original height in winter, adds to its allure and mystique. It serves as a living testament to the interplay between human ingenuity and the natural world, showcasing the ways in which engineering must adapt to and harness the forces of nature. Visitors to the Eiffel Tower may marvel at its size and grandeur, but few realize the subtle changes it undergoes with the seasons, a reminder of the ever-changing environment in which we live. This phenomenon also provides a fascinating insight into the daily challenges faced by engineers and architects in maintaining and preserving historical structures. The Eiffel Tower, over 130 years old, remains a pinnacle of engineering excellence, thanks in part to ongoing efforts to monitor and address the effects of thermal expansion and other environmental factors. These efforts ensure that the tower remains safe, stable, and accessible to the millions of visitors who flock to it each year. In conclusion, the fact that the Eiffel Tower grows taller during the summer due to the thermal expansion of iron is a remarkable example of the intricate interplay between materials science and structural engineering. It highlights the importance of understanding the physical properties of materials and their responses to environmental changes. This dynamic characteristic of the Eiffel Tower not only underscores its status as an engineering marvel but also enriches our appreciation for the complexities involved in maintaining such an iconic structure. Sharing this knowledge with others can deepen our collective understanding of the natural and engineered world, fostering a greater appreciation for the hidden wonders that lie beneath the surface of our most beloved landmarks.